All right. Hello, everyone, and welcome to Handmade Hero, show where we code a complete game live on stream. I'll be honest, yesterday's episode was pretty interesting to me because I had never really thought, not only had never really thought about it, but I've actually never even seen anyone talk about it or do it. I mean, I can't imagine we're the first. It doesn't make much sense for us to be the first. But the stuff we discovered on yesterday's stream about using sign distance fields to interpolate lighting properly, lighting fall off properly, or I shouldn't say properly, but attractively, I've literally never seen that before. So that was complete news to me when I sort of investigated that and it turned out to work. That was shocking. And so I'm kind of interested in this, and I want to kind of follow that to its logical conclusion. So today we're definitely going to continue experimenting with that and see what we can do with how many voxels. We know we can sample a large number of voxels at runtime, and it doesn't seem to have a particularly large cost. Like, it seems like the graphics card is pretty good at sampling voxels. And given that we can sample what appears to be a fairly large number of voxels, and we know we can interpolate sign distance fields quite well, it kind of starts to beg the question of, well, wait a minute, like, what kind of interesting and novel, at least to me, well, like I said, I can't promise that we did this first because there's a lot of graphics research out there. There's probably someone who's already discovered it, but it was fun to discover it independently, let's put it that way. Since we know we can interpolate sign distance fields quite well, and we know that we can interpolate normals, it appears like, pretty well as in addition, it sort of starts to beg the question of, like, what is the most attractive light reconstruction scheme, and how can we sort of, like, lean on that in our output phase to, like, make really good looking lighting from pretty low resolution sampling, right? So I'm relatively excited about that. I've literally never seen anyone talk about anything like this before, so I'm pretty interested in that, and I like when I find out something new. So, like I said, I'm not sure we invented it because it probably exists somewhere. That's the nature of graphics research, is there's so many people who do it, and there's been so much attention paid to it, that it's very unlikely that when you discover something, you actually discovered something. So there is that. But that said, I certainly am interested in the fact that we did independently discover it, and I'm pretty psyched to sort of, like, see where that leads. So as you can see, we are currently, here's our little interpolation test, and the really interesting thing about this test, and again I'd like to just underscore just how interesting it was to me, is if you look at what's going on here, this is actually voxel reconstructed lighting from a spherical light, right? And the thing that's really remarkable about this is, even though there is literally no direct lighting computation occurring now, there is none. We are not directly computing lighting at all. The pixel shader does not know where the light source was. It is literally reconstructing it simply from a voxel intensity, right? It looks as if you've performed direct lighting, right? Because what we did with the sign distance field light interpolation actually is able to reconstruct a real sphere from samples that are just on the voxel, right? And that is pretty remarkable to me because I've never seen that demoed before, but it's really kind of cool. And just to underscore how interesting that is, if we are to look back at the actual, like, what it looks like when you don't do that. So if you do not reconstruct with a sign distance field, right? If you actually reconstruct with just light intensity, which is what most people do, as far as I know, the only kind I've ever seen was this kind. If you reconstruct with light intensity, let me show you the difference, right? So this is what we were looking at before. And this is, oops, I did that wrong. Forgot I have to do it this way. There we go. So, you know, this is the way we were doing it before. And as you can see, it's like perfectly spherical, right? When you actually switch to doing the kind of light interpolation people normally do on a voxel, look at how ugly that is. Do you see all the, like, rectilinear artifacts from that, you know, from that voxel sample, right? It's pretty bad. You can really see them very clearly. And all we did there was switch from interpolating light intensity to interpolating a sign distance field that represented light intensity. And again, the difference there is strictly in whether or not you allow the values to go negative. And one of the things that, is really kind of non-intuitive is that when you are using a reconstruction filter on something, truncating values creates artifacts. That's what happens. So even though you would normally say, well, why does it matter if I truncate a value if I know that the light intensity is 0 or -1 or -10 or whatever, why would it matter if I truncated all those to 0? Because they still represent no light contribution. And the answer is because it changes the shape of your interpolation. So you must interpolate first and then clamp if you don't want to introduce artifacts, right? And so that discovery was really kind of novel to me because I'd never heard it mentioned in the context of lighting, and I'm really interested in that, and I think that was cool. So now what I'd like to do is just take a look at what can we now, like, let's suppose that we embrace that and say, if we're gonna take all of our lighting information, which at the moment, like I said, this is just a test sphere that we're jamming in here. And so what we're looking to do is finalize this sampling layer as something we can dump our actual light contribution information down into, right? And so what I'm really interested to know is if we are going to output our lighting in this way, what can we do? Like, what is the best way to set it up? And how can we really leverage the fact that this is producing really nice reconstruction to sort of really create something that allows us to get a lot of lighting expressivity in here, right? Because again, if this is all I wanted was like a little like flashlight effect on the player, then we're kind of done. But if I was doing that, I wouldn't need the voxel, right? But what I want to do now is flood this thing with tons of lighting information. Like I want all of the bounce light from the ray tracing, and I want all of the, like, lots of different light sources and all there. That's what I actually want to do, right? And I kind of want to make sure that we have, like, the best possible setup for that, right? And so, yeah, that's all. So what I'd like to do now is just say, let's push this a little further. And furthermore, let's see how much detail we actually need in the voxel. Because it may be that our voxel now is still too detailed and we probably could get away with less, is it? All I'm thinking, right? So for example, like if we take a look at the actual striping of the voxel, so if you remember correctly, we've got like a thing here where I think, at least, I can switch to look at the voxel striping. And just give me some input into, oh, well, I guess not. Didn't we have a way to get voxel striping in here? Oh. Oh, wait. No. That was that was the wrong thing. Yeah. Oh, boy. So, I guess, I don't know, maybe this. We'll do it. Not sure. Let's take a look. No. So we're packing north and south light directions in here. Light west is the only thing that actually has any light information carried in it at the moment. So shouldn't that have worked? Shouldn't that have striped? Meaning this right here, where we stripe the west with a full red. Oh, because it already is. Never mind. All right, yeah, obviously that won't do anything. Never mind. I take it all back. That's not gonna do anything. Like, let's just say we then don't do something. Well, okay. Maybe we just do this then. Does that help? That didn't help either. All right, you know what? We're just not even going to bother with that right now. I want to take a look at the voxel resolution one more time because I'm not sure what resolution we need. You know what? Maybe, yeah, I'm gonna. So what I want to do here is I would like to make this actually work with, so that I can turn on voxel striping here in some way. And we've kind of got too many cases here. So maybe what I'll do is I'll just like sort of duplicate this one entirely, right? And so I'm gonna pull this out, the part where we assign it. I'm gonna pull that out, and I'm gonna pull it out down here. I'm gonna get rid of this, right? And what I want to do here is I'm gonna make the definition of these things, the light west, all that stuff. I'm gonna make that just be in here, period. So we can make this loop a little bit more sensible, right? Because I'm kind of just piling all this test stuff in here, and that's not necessarily the smartest thing to do. So let's just try and clean this up a little bit. Just because I would like to take a look at the resolution and just understand the effects of the resolution on the reconstruction. That's what I'm trying to do here. Just kind of get that a little bit more under control. All right, and so what I'm gonna do here is just have these parceled out. So what I'd like to do is have a pound diff here, which is like pound diff like test light sphere or something like this, right? And here is that code. Then we're gonna put an end-if in there. So now we have the test light sphere. Then we're gonna do another one of these, which is like, you know, pound diff test light checker board, and that'll be this crap. And then we'll finally have one that's like if test light probes, and that'll be this garbage right here, right? And so now I can just like turn these on and off with like a, you know, pound define basically, and it'll be a little bit clearer what the heck is going on. So if up here I do a pound define test light checkerboard, now I should be able to just have this test light checkerboard code turn on. And what it should do if I compile it now is I should get like nothing on the screen, right? Because I don't have any lighting getting fed in there. If I now initialize these, so light west is going to equal some amount of light, and light south, light north, that's where we were packing the normal information in. So since we don't really know what the normal information should be necessarily, I'm just going to pack it in as like all ones or something, or something like that. So we'll just say like light south is going to be like something like that, which is not really correct, but I just need to stuff something in there. Light south, no, sorry, it's like north. So I just need to stuff something in there so it'll be, you know, relatively correct at all. Why am I not seeing anything? So light west, those should come in here, right? I think that should be correct, right? Did I change the way that... Oh, I did. I changed the encoding so that actually wouldn't be very much light anymore because it's biased now. That's the problem. Okay. Remember we biased our lights to do specifically that sampling, so I need this to be brighter. It needs to be at least like A or up probably to be a bright light. Yeah, there we go. All right, so that was definitely our problem. All right, so you can see the sort of checkerboard pattern here now. Obviously, we don't actually get a checkerboard pattern here because we have interpolation turned on, you know what I mean? But if you look at like how dense the checkerboard actually is in practice, and we could go turn interpolation off. In fact, you know, that's maybe something we do want to do when we're taking a look at it. But if we look at how the interpolation's working here, you can see that it's still a pretty dense voxel. It could capture some fairly, even at the most zoomed out that we would be, it's still pretty, you know, it's a pretty dense sampling. And you can see like it would still be a little wider, like it's not, we're not like properly sizing the lighting region at the lighting voxel region at the moment, so, you know, it would be a little wider than this. But it is kind of an open question to me, is like, did we actually need it to be this dense, right? And so what I want to see is just like, let's suppose, I'm just curious, and we're not, we don't really need to go down a level here, so I'm not sure I will keep this even if it works, but I just want to know. So if we were to change the voxel resolution here, right? So here's our voxel. If we changed it down to an even less resolute voxel there, right? So here's our much less resolute voxel. So you can see that the bands are sort of much bigger and blockier now, right? So if we switch to something that's much more low resolution like that, my question is, what happens if now we try to reconstruct the spherical light again? I'm just curious, like, how bad is it as you look at, like, how good is this reconstruction filter? Like, as we start to step down the resolution of the reconstruction, what do we get, right? And I don't know. All right. So, I mean, again, really interesting. I mean, look at how good that reconstruction is. I mean, you would never know. Like, look at how detailed it is, right? And again, that's just because sign distance fields can be reconstructed properly with bilinear filtering and trilinear filtering, right? And so you look, it's like you would never guess that the sampling, that the actual image that you had to reconstruct that from was, you know, was this resolution, right? Was this, right? At that banding level. I mean, another way to look at it would be like you look at this, and you see like this, the sphere there, right? And then you go to the open gel layer, and you turn off like geolinear or something. Right, and now if we actually recompile this and rerun the with a render that doesn't have the bilinear filtering turned on, right, or trilinear filtering, then what you can see is that's the actual resolution of the light. Like, that's what we're storing. You know what I'm saying? Very, very sparse there, right? And it's just really remarkable to me that we can reconstruct lighting that smooth from something this coarse. And again, that was just the sign distance field was such a cool thing to use there. I'm really stoked about that trick, right? So anyway, let's go ahead and now try to poke at this thing and see what we can do. So, what I determined last time, and I don't, like I said, I don't know. Maybe we'll just use it at that low resolution. I'm not sure. I don't know if that resolution gives us enough verticality. That is one thing I'm a little concerned about. I don't know to what extent we're getting sort of a. I don't know to what extent, if we were at this low resolution, if we would get enough gradation there. I think we do. You know, I mean, it's crazy, but I think we could get away with a voxel that small, right? I don't know. I want to say we probably could. Just looking at that, right? And that would be so cool, right? I mean, that's such a small amount of information. It's really pretty neat, right? So anyway, if we come through here and we basically say, like, okay, you know, we are gonna, you know, use the reconstruction filter. It seems to work pretty well. We want to kind of do sign distance field interpolation as much as possible, because to the extent that we can, we want to make sure that we interpolate the boundaries of these things, you know, well. And so if we take a look at what we want to encode now, I think it's pretty different than what we were encoding, because, you know, we switched that. We looked at the box model, the four corner box, the six direction box model. I think that's garbage. I don't think we want that. We saw that it had artifacts when we used it. So I think we kind of want to change the way we're looking at this problem. And I think what we want to do is look at it as there's some number of sign distance fields for lighting, and we're going to output like 3 sign distance fields or something for lighting, right? Something like that. So if you imagine how we might encode these, like imagine we did something like light field normal 0, light field color 0 or something like this. And then we just have like a couple of these. So we're basically saying like, we are going to put down some light fields. The light fields will have a normal and a color. And it's up to the lighting system at the head end to generate something, whatever that something is. Generate something that fits into these light fields well and can be reconstructed as part of the lighting model. That will be as continuous as possible, right? And we know that this is it's not trivial to do, because the light fields, it's not just 3 lights in the world, right? We have an arbitrary irradiance sphere at each light probe, arbitrary lights coming in, bouncing off the walls, coming from direct light sources somewhere, who knows what it is. So the actual light that we have coming in, there's just like a ton of information that we need there, right? And so we need to encode these light fields somehow, and I'm going to pick this way temporarily. It may be that we want something more like spherical harmonics or something like that. Since I don't spend a lot of time thinking about problems like those, I'm not sure. Because basically, like, the way to look at it is interpolating normals in a light field versus interpolating parameters of something like a spherical harmonic. A spherical harmonic is basically like decomposing a light sphere, an incoming light sphere, into the sum of functions that are like sinusoids, or you could think of them as like positive and negative lobes, right? And so there's 2 ways we could look at this problem. One is we're going to interpolate light fields, and we're sort of fixing the directions where we are talking about those. And, let me... Here they are. So if you think about spherical harmonics, right, what you're really talking about is coefficients that tell you which of these you are adding to your light, incoming light, right? So the first coefficient of your spherical lighting is just the incoming light from everywhere. So there's a ubiquitous like ambient light, right? It's just it's a baseline value, right? The next set of coefficients are 1 each for these 3 different sort of directional positive and negative lobes. And it doesn't matter which one of these you think is positive or negative, really. But basically, like positive being green and negative being red, right, in this case. So whatever the coefficient is, it adds light here and subtracts light here, right? Then you have one more coefficient, adds light here, subtracts light here. One more coefficient, adds light here, subtracts light here. So a 4-parameter spherical harmonic deconstruction would give you this much control over your light, right? And you just have to decompose whatever the amount of lighting is that you thought you wanted, right? You just need to decompose it into that. Similarly, if you wanted to go one more step down the ladder, you could afford by adding 4 more parameters. Unfortunately, you'd kind of need a 5th one here to capture that last one if you want the one more rung down, right? And I don't know what people typically do to try and jam I012 into, like if you want that extra level of detail. I'm not sure what they do. But, we could also go hog wild. So if you count how many there are here, right? There's 4 here, there's 5 here, and then there's 7 here, right? And so 7 plus 5, right? If you were to look at these 2 levels together, right? Like 7 plus 5 is 12. 12 is 3 more texels, right? So if you were to imagine storing these in the voxel, if you just go like, well, all right, we've got 4 elements here and 12 elements here, that's a total of 16 elements. We could just do that in our voxels, right? So we could do a spherical harmonics version that was basically just these lobes and interpolate that, right? And that would just work, I think, right? And that's one way to that's the way we would reconstruct our lighting. It seems pretty compelling, right? Because we know we can look up that many things in our voxel. We know that 16 lookups in the voxel is only 4 voxel reads, right? Because each one comes back as 4 elements. And so we could pretty easily say, well, you know, there's our spherical harmonics right there. And we just look it up and we do the computation, right? So it has some compelling features to it. It seems pretty reasonable. But the problem that you get into pretty quickly, if we were to go that route, which is interesting, problem we would have right off the bat, no colored lights, right? Because these coefficients just tell you the light, the amount of light. So if we actually wanted colored lighting, we would need to multiply whatever value it was by 3, right? So our spherical harmonics would be something like this. If we wanted to go all the way down to this rung here, that's what we would be looking at, right? It's arguable that we don't really need to go that far down, right? Maybe that's too far down. So maybe we would only do 9 here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Those 9 parameters, right? Maybe we would just do 9, and if we do 9 times 3, right? That's how many coefficients we would need, and we know we can look up 4 in a go. So that would only be 7, right? So if we just cut it down a little bit, this would be what we would be looking at, right? 1, 2, 3, 4, 5, 6, 7. And we know we could do that, no problem. So spherical harmonics down to L2, right? Not a bad idea, if I'm honest, right? It seems kind of, maybe, sort of, a little bit, not so much, possibly, who knows. Like, that could be interesting. And the reason that could be interesting is because it gives us sort of a formal way of figuring out how we're going to talk about the lighting, right? And, you know, I guess, like, the alternative of having a direction and a coefficient, I don't really know of any. There's not really a lot of ways we could produce if we just wanted 3 light fields. So if we just did something that looks like this, then we're kind of off again with no particular theoretical guidance as to how we produce those fields. It's kind of just a random thing. You know what I mean? And so while stuffing those directly with test lights may be easy because we can trivially produce 3 test fields by just generating them directly, that doesn't help us when we go to take the result of our ray tracing system and dump it into these light fields. The question is, well, how? You know, like, how do you decompose something? And what we would need to do is like some kind of like principal component analysis or something, right? I mean, we'd have to do like, well, store some kind of a, you know, store some kind of a system that I don't even know. So I'm not sure. So it kind of seems like, you know, I believe that you can, because these are linear decompositions in a sense, right? I'm pretty sure you can just add them together, right? Let me just make sure that's true. As usual, the Wikipedia page is less than easy to parse. But my assumption is we can just add the coefficients, or roughly thereabouts, right? Since I never work with these, I can't say that definitively, unfortunately. Yes, I know. I don't care about that. Oh, that's a cute little... So I guess I'm not sure. I mean, here's what I'll say. I would be shocked if you can't do that because it should be a decomposition that should be able to be added together. I mean, that's the whole point of the coefficients is in the first place is they add together. So I can't see how you couldn't add them, but I just wanted someone to actually say that who studies these for a living, just so I know that I'm not crazy. Um, yeah. This is kind of a nice way to visualize it, don't you think? So here what they've said is basically like, oh, okay, here are the coefficients visualized by what they do to a cube map, essentially. Um, and that makes it pretty easy to visualize, much easier than this way, I think. Right? Because you can sort of see directly what's happening on a cube map. Maybe it's a little bit easier than trying to picture what negative light means there, right? But yeah. Do, 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 do. How is it possible that it's not just stated in one of these things right up front that you can add them together? Am I like wrong somehow that you couldn't add them together? Because that would be weird. Just looking at the math here, I mean, I can't imagine why you couldn't. But I wanted someone to say that. Is that wrong? Is it wrong for me to want someone to say that? So yeah. Hmm. So I guess the problem here is I would want to read up on these a little bit more because the fact that that's just not said right off the bat was a little weird to me. and I'd like to be more comfortable than before I would pick that as something that we would like try directly. I can't. I mean, if it's a decomposition into a series of basis functions, you should just be able to add them together, right? Because the entire point of a decomposition like that is that you are summing them together in the first place. And so you should be able to sum, two separate decompositions together. It's important that that be true, because if that weren't true, it would make them very hard for us to work with in the case that we actually need to know. Which is to say, we need to update a state of these things, kind of as for each light probe and whatever, right?
So yeah, it's a little bit weird there. I'm not sure what to make of that exactly.
The other thing I would say is one problem we might have if we try to do something like spherical harmonics is I wonder if we would run into the problem of not being able to do negative interpolation like we're doing. I think we'd probably, well, no, we probably wouldn't. So the problem with spherical harmonics as well is that since they have a positive and a negative lobe, it means that the trick of interpolating past the zero value that we're using to make the interpolation look good currently might not work, right? Because a spherical harmonics system is not one that you can arbitrarily shift around like that, because it has an actual zero around which it is defined. And I guess I'm just not sure, that I can necessarily convince myself that the trick of making sure you can interpolate past the zero values would actually work. I think it might not. So it may be that we actually couldn't use those even if they can be added properly. So I guess maybe I'm not sure that would really be good. I guess as much as I'm not sure how exactly we will accomplish it, I guess I'm going to start down this path with the experimentation. I'm a little nervous about the spherical harmonic side of things because I just don't necessarily see the interpolation working properly there on the sparse level. It seems like that might just introduce artifacts again. And maybe I'm wrong about that, but that seems like what would happen. But it's hard to say, right? Let's start down this road and we'll see how I feel about it as we go. So let's suppose we change the samplers to be 6 samplers, normal plus color, and we're just going to leave it like that for the moment, right? What did I call it? Light field? Yeah. It should be light field sampler though, right? We'll keep it as light sampler. So it's pretty confusing. It's true, but we'll figure it out, right? We'll muddle through it, and we'll figure out what is something that works well in this scenario. So if we change over to light sampler, and we've got like an N0, C0, N1, C1, N2, C2 there. And then what we do is we change the way this stuff's working such that, that doesn't happen anymore, right? And I guess what I don't really know if there's a good way to tell the graphics card in this particular case. Maybe we want it to use its own unpacking rules. So let me just take a quick gander to see if there's something smart to do here. So assuming we're going to specify textures, here's sort of what we've got, right? And if you look at how these things are defined, what you can see is we can just choose to use like an S norm value or something, right? And an S norm value is something that's going to tell us like something that's binormal, like when we encode the normal, we're encoding a positive negative x, positive negative y, positive negative z. So, using one of these RGBA8, for example, values is not probably what we want. So we could easily switch to something like this, which would allow us to encode something that had signs in it. So we don't have to do the biasing ourselves. It's just the graphs card just does it automatically, which would probably be a faster path, right? I don't know because I don't necessarily know whether it just inserts shader instructions to fix that or not, or whether it's actually done in the texture unit. That probably depends on the card. But assuming it could do it in the texture unit, it's more efficient. It's less ops in the pixel shader, right? So looking at this, it's like, well, yeah, we've got some options. Honestly, that looks pretty compelling. Unfortunately, not signed. We might still want to use it, right? But what that is it's saying take the 32-bit value, only encode 3 things in it, but get me more bits, right? Get me more bits of precision. And that seems pretty good, right? I mean, that is sort of what we would want for encoding a normal in there. And we would just have to do the bias ourselves. So that's, maybe that's not our favorite thing, but, it's something. Certainly. So I don't know that we've got an option in standard GL here that would give us that but signed. I don't see any formats in here that really do that. I mean, there's versions where everything's 16-bit, but I think that's overkill. Something like this I think would be more what we would want. But there's no S-norm version. So I don't really see any way of getting that for free, just looking at it. I don't see it. So we may just want to use a format like the R11F, G11F, B10F. We may just want to do that and say like, all right, we know that we've got 11 bits, 11 bits, 10 bits. So it's pretty easy for us to encode negative values or not. R and R11, G11 are both pretty clear. You've got 1 bit for sign effectively. This one is unfortunately unbalanced, so this one has the normal bias problem where you've got 1 bit, value more on one side than the other. So, not the end of the world though, because that would have been true. That was true for our 8-bit encodings as well. So that's not a huge deal either way. But point being, we could just use something like that, which does seem pretty compelling, I guess, at the end of the day, right? So maybe we try to do something like that. Let me go ahead and put that pound define in there. And let's get did I do that wrong? R11F. Yeah. So we really just need this. And we could ask for these textures to be stored in that format, right? Gosh darn it, come on. There we go. So if we were to just say, look, inside our texture creation, inside the OpenGL layer, as we go, we want these samplers here to be using buffers that are, encoded a little bit differently. That shouldn't be too hard. So during init, when we actually specify those textures in the first place, which is like right here. So when we're actually specifying these, we could say, all right, we actually want 2 separate ones here. So the lighting data, in this case, actually is not stored uniformly. We want to do, and well, honestly, looking at it, we could choose to store them all this way, right? Because we also only need an RG and a B value, actually. So, we could choose to store the colors this way as well. I'm just not thrilled about that, and the reason I'm not thrilled about that is because I don't super love, for lighting, the idea that we wouldn't really be able to represent gray. If you have, more bits for RNG, I'm worried that we wouldn't be able to quite exactly unpack those in a way that would allow me to do grays properly. I don't know. Or you would. It's not that you couldn't do grays properly. It's that you need to do extra work to make sure you didn't accidentally produce yellowish or bluish light because of the fact that you have more precision in your R's and G's than you have in your B, right? So I don't really love that. So I guess what I would say is, yeah, not sure I want quite exactly that. But point being, if we go and look at the information we're actually storing with the light data here, then inside the OpenGL light data array there, we've got light data handle, which is this. What I think I'd like to do there is say, let's split this up into light fields here, where we say, okay, let's say we've got light data handle N and light data handle C. And what we'll say is, we don't know how many light direction counts we want. So we're going to just say, we've got a max light direction count here. And that way we can vary it. Because in the future we may decide we only need 2, or maybe we need 4. And since we don't really have a good handle, we're very much experimenting with this. And maybe we won't say max. Maybe we'll just say light direction count, because honestly, it's how many you use. That's how many you will be using, period. Right? So let's say we just pick a number for that, and off we go. Then in here, where we've got the light data that comes down, we know that we're going to have 2 different versions of the light data that comes down here. And so we're going to have a light direction count in 2 cases, like this, and we're going to have a normal and a color channel, like that. And so, again, not really sure how I want to do this, but I'm just kind of giving us the pipeline to have 2 different formats here. So that way we can try storing the normals with something that's maybe a little bit different than what we're using to store the color values, because the color values are sort of getting packed in a way that makes us want to have HDR, so RGB exponent kind of a packing. That's the way we're sort of looking at it right now. But the normals, on the other hand, are not that, right? The normals are going to want to just be what's the best way we can reconstruct 3 arbitrary values from -1 to 1, and off we go. And just to underscore how much different that might be, it's a normal, right? We know it's normalized. So in addition, what we might want to do is switch to literally just something that's more like a 16-bit value, where we've got 77 or 781, right? Because we know that we can encode the normal as just 2 values, right? The x and the y. And we can reconstruct the z by just taking the square root of the squares of those values, right? So because we know that it's normalized to begin with, we only need 1 additional piece of information to determine whether the normal is pointing up or down, basically. And that's the sign bit, whatever the sign bit is on the z value, right? So we may just encode them this way and leave it at that. We may want to go one step further and say we can make this get even more precision, or take even less space, depending which one we want to do. Go down to 16 bits or stay at 32 but get more precision in our normals by just encoding them differently, right? So again, I think we really want the flexibility to encode our colors differently from our normals, because there's a lot of ways that we could consider encoding either of them. And so we probably want 2 different texture formats, would be my guess. I doubt we're going to want the same texture format for both of those lookups, right? That's just my guess. So anyway, let's go ahead and follow through the compile errors here to guide us to all the things that we need to replace in order to do that. So in this case here, you can see all I'm really doing is saying, hey, let's take these handles, right, and actually construct them like so, based on how many there are in each one. So we're doing both of those. Then what we'd like to do is loop over to them separately. So in these two cases, like I'd like to make two separate ones, right? I just don't think I necessarily need to be that sort of verbose, because maybe because what if we want two different ones? No, so I'm going to say light direction count goes here, and I'm just going to go ahead and say that it's always symmetric like that. All right. So when we come in here, what we do is we're going to set up these, and I need to take this value that we were using here and put it up here where we're doing our GL identifiers. So here's a bunch of formats, and here's one more format that we want there. So when I actually go to do this, we're going to generate texture handles for the normal texture and the color texture. We're going to do a light direction count of each of them, and then here we're going to specify them. So the first thing I do is I specify the light data handle for the normal, let's say, and then the next thing I do is do the same thing but for the color, right? Now the color probably stays the way it is, right? So that's probably what color does look like, because we're going to be encoding that exactly the same way. However, the normal doesn't. The normal, we're sort of saying, look, we're going to ingest this somehow, and then you're going to encode it like this, right? And what I don't know, I'll be completely honest with you, is I don't really know what the hey they want you to say there in terms of how this stuff comes down the pipeline, right? So, if I want to specify one of these, how do I give that information to the actual graphics card, right? And I do not know. So it would be nice if that were sort of discussed somewhere. What I'm going to guess is that if I look at the original extension that talks about when this was added to OpenGL, somebody will tell me how to actually submit these, but I don't know. So let's find out, right, where these are supposedly going to go. So it looks like you just can specify them any way you otherwise would, maybe, right? So I don't know. Maybe what we would do here is specify these as float and let it do the packing, because 3 floats versus 32 bits. I don't know. Maybe we want to compress those first. Maybe we don't. I'm not sure. But I'm going to go ahead and say, at least for the moment, we're not going to do that. And so what I'm going to do is say, look, we're going to specify this as RGB floats, and you will compress it into RGB this way. And so those arrays now will not come down as any kind of weird packed nonsense. Instead, they're going to be just the original floating point data, and you can go ahead and do whatever you want to do with them, right? Again, maybe that's stupid, maybe it's not, I don't know. We're making this up as we go along here, so I don't have any preconceived notions of what has to happen there. If we do look at how we're going to submit them, though, then what we would end up saying is, well, these are going to be F32s, right? In a sense, not really, more like V3s, right? So we're going to specify a set of V3s. The light probe position stuff, again, is not stuff we actually send out. So it's really, we kind of want to isolate this a little bit and say, all right, this is what this is the actual lighting bundle. This stuff is stuff used in lighting computation, right? But we don't need to send it down to the graphics card yet. Someday, maybe we do the RTX implementation of this stuff, and we do send it down to the graphics card and be like, here you go. But at the moment, we're not doing that. So what we're doing instead is we're just saying, look, we're going to submit these ourselves here. And we're going to submit the normals as normals now, okay? So after we generate that out, I don't think there's anything else necessarily we need to do here. The color data will stay the same. It's the normal data that will change. We're going to have to go to the command buffer here, and say that also needs to change when you look at how these things are getting sent down here. All of this stuff is kind of a little bit wrong now as well. So if we look at, I don't know, a lot of this stuff is kind of incorrect at the moment. So if we look at what's coming down here, we've got the, well, actually, hold on a second. I'm not actually sure exactly how those were getting pushed. So let me just check real quick. Okay, so basically this is now just wrong. You know what I mean? Because when we're even calling it the wrong thing, because it's not a light index voxel anymore. But what are you going to do? So this is going to be the light voxel, and this is light voxel C, and this is light voxel N, right? And what we want to do here is just say, all right, it's not 6 anymore anyway. It's 3, I guess, in a sense. And we're just going to have 3 pointers to the different pieces of data that's going to come down, right? That's what we were sort of saying before. And now, instead of a U32 here, that's going to be a V3. So that's what we want to actually provide. And then the light voxel just tells you how big those things are, so you know how to pack the values into them. And alternatively, we could just expect you to stride it, but I'm not going to do that. I'm going to put them in this way, right? So now we go ahead and recompile, and again, just let the compiler tell us where we need to fix this stuff. So the light voxel dim here, right, this is just going to change to being called that. And then what we need to specify here is actually, when we're packing the commands in here, we just need to say like, oh, here's where the, here's where the N's are, here's where the C's are, and now we just have 0, 1, 2, right? And what I'd like to do there is say, well, can't we just make this be a little bit more specific though, and make it so that this will grow as we need it to, right? Because we may want to change that pound define. So I think I'm going to instead do this way, where we do like, an index here, and I just say light direction count. So that way, if we decide we want more of these in the future, we just get them, and we don't have to rework this code at all. So what I want to do is this, right? And I just want to say, initialize these out to the light data that we are asking you to store here. And hopefully that just kind of works. That is apparently not called that. It's just called light N and light C. Let's make it called light data instead. All right. Again, this now needs to kind of change a little bit. So when we're submitting these textures, we need to submit both versions of the textures. So here we're actually going to be saying like light direction count. Yeah. And here we're going to be data handle. So now, I don't know why it's called light data handle, but it's just, well, whatever, it doesn't matter. So anyway, here we're going to be binding twice now. We're going to be binding to the C handle and to the N handle, right? So as we go through here, now we need to submit these differently. The C handle will still look exactly the way that it did. The N handle will not. That will be submitting actual floating point data here. And that should just work. Hopefully, famous last words in GPU land, but what can you do, right? We have not that many more to go. You can see here we need to actually bind these things, and so we're going to have to figure out how exactly we want them bound. My sort of assumption here is we might as well just bind them alternatingly, exactly as we were before. So maybe we just do this here, and we say that it looks like that. So we have the N and the C's alternating. So we start at 2, and we multiply this value by 2, and we just line them up in that order, right? And that's if we want them interleaved. If we didn't want them interleaved, then we would just do 2 loops and be done with it. But I think that seems fine, right, for now. So that's NC, NC, NC. Okay. Moving on, we need. Oh, sorry, that's light voxel dim now. Moving on, we need some way of actually somewhere in here when we're doing our lighting, we should actually. I guess we have to change it in the ZBias program because I don't think we're going to get an error on it, but we need to actually fix it. Somewhere in the swing of things, we're going to have to actually put in a thing somewhere that will properly query those. In fact, I'm just going to do that while I'm thinking of it instead of finishing what I was doing there because I just don't want to forget and not do this because we need to do it. So you can see we got the light samplers here, NC, NC, NC. And so what we need to do is make sure that those are lined up. Well, you know what? I didn't need to do it because I already did it. I was going to say we just need to make sure those are lined up properly. And so now they are, right? All right, so that seems fine. Never mind. In here where we've got our light voxel fill out, this routine needs to now change. And that's because looking at the light voxels, now this doesn't really make any sense. So what we effectively have now, instead of what we were doing before here, and also, by the way, we might as well do like something like this. Just in case we want to change that addressing scheme. No sense cutting and pasting it all over the place like that. So when we stream this thing out and we've got our light voxels, off we go. You know, and another thing that honestly we will probably want to look into, and I don't really know to what extent we have the ability to do this, but really these are all one voxel. The only reason we have multiple voxels is because we're trying to just make sure that we can just do standard encoding, right? And the problem is that we don't really have any way of saying to the graphics card that I know of in OpenGL 3, I don't know if there's a way to say, look, we just have one lookup. We want, 32 color values out of it, right? So I don't know if there's any way to really do that, but, it's worth noting these voxels are not really voxels. They're not really 6 voxels. They're one voxel that has 6 values in it. And I just don't know any simpler way in OpenGL 3 to say, hey, just do this, right? All right. So if we're going to supply these values, I guess what I would say is right now, I think we can only specify the first one temporarily, and we'll actually sort of put stuff into these a little bit later on. And so I'm going to say that we're going to specify here the N and the C. This will be like light N0. This will be light C0. And so a lot of this stuff now is not correct, right? So we're going to have to rewrite this code a little bit. Test light checkerboard is probably pretty easy. We're just saying that the light normal in this case, right, is going to be a V3. And who knows what the V3 should be. Maybe it's that. I don't know. I don't care. But the light color in this case is actually fine. It's exactly what we were doing before. And so what we were stuffing into light west is just what we will stuff into the color value now. You know what I'm saying? So that looks like this. And good, good deal. When we come up here and we take a look at what this is doing, then again, right, the test light sphere part of things, which we kind of want to change a little bit. And I'm going to actually make this have the variables we now need. So when we come through and do the light test sphere, now we don't really need to do any more of this like crazy dancing to like do the light north-south pack, right? The light N0 just is the value. So right here where we do light N like that, all we need to do is like assign that now. So we just do light N 0 equals light N, and that packs it. Light C0 now just needs to be whatever the light west pack would have been, right? And the rest of this stuff goes away. Goodbye, right? And so that's the entire repacking of the sphere now. And when you look in here, you can see, like, all right, we don't really care about this stuff. This is now not necessary either. And none of that is necessary. And none of this is necessary. It's all nonsense. So really all we need to do here is where we pack in the light alpha value. Here where I was doing that, it's really just this, and then we're done, right? So I think that's all we really need to do to pack these values, to place these values into the voxel properly. And then, oops, I need to clear those out. And then we just need to clean up our compilers and debug. The light voxel here, where we are assigning it, again, just needs the NCs. I don't know why I skipped those. This is going to need to be a cleared v3, I guess. Well, you know what? I specified these at the top now, so I can actually fill them all out. And then we can start playing with them up in the loop, which is what I wanted to do anyway. Right? Oops. Got a caps lock value on there that was messing with me. All right. Caps lock. Do we still need it? Why is it there? I used to rebind it to control, but I like those keyboards that just does that automatically for you. All right, and so now I guess we don't know what will happen, but probably we need to fix some things. Oh, right, duh. We haven't rewritten our shader. So last thing is we got to call this getIrradiance function with the correct stuff, right? And so when we look at the samplers in here and we're pulling these values out, we need to start talking about these in terms of not our weird cube anymore. We need to say, like, let's get rid of that. That's not relevant. And so we need to start sampling based on like the normal and all that sort of stuff. So what we want to do here is say, all right, we're going to have 3 of these getIrradiances. And what we're going to do there is say we've got a light C0, C1, C2, and then we've got a light N0, N1, N2, right? And we don't care about any of this crap anymore because we can directly encode normals now. The graphics card is like doing that work for us, right? Furthermore, this doesn't need to look like that. This can just look like this. So we can basically just get the irradiance that way, right? All right, so that's all good and fine and whatever. When we come through here and we're doing our sunlight, when we're actually doing our lookups now, what these will look like is we've got a C0 lookup and an N0 lookup, right? The N0 lookups, the N lookups will all just be looking at the XYZ components because we no longer will have anything in the alpha channel. It'll just be blank. So we don't want to look at that because it's encoding, like the encoding we chose was RGB, so the alpha channel will not have something in it. It's a non-channel, right? We only get 3 channels out of our text lookup. The C does get 4, just as it did previously. So that's all fine. This is what our total lookup looks like now, and then the irradiance happens as it would have happened before. This should all be basically the same. The encodings are all the same. The only difference now is instead of the light direction being hard-coded to a box, it's actually coming in as its own channel, right? And, you know, color me a little bit surprised that worked the first time out. What I will say is it's not correct, so we still do have an issue here. If you look at the way that this is responding, the normals seem incorrect there, right? And I guess, you know what I just realized? We didn't, I forgot. I literally said this and then forgot. That RGB encoding doesn't supply normal, binormal, right? That RGB encoding, I literally said this and then just completely forgot as I was making all those changes, right? It doesn't do the positive negatives for us, right? That's the problem. So like this, they're not signed. We want them signed, they're not signed. And so we fundamentally have to figure out how we're going to reconstruct signed values from those values. And there's a lot of ways that we could do that, right? But I guess what I would say is when we come in here to do get irradiance and we have this light normal and this light value, and you can see us like decoding that stuff in here. Like, for example, you can see the light color getting decoded this way. We now need the light normal to be encoded as well. So this light N is not really a light N. It's like a light N encoded, right? And in order to produce the light N, we need to actually do some real work, unfortunately. Right? So in order to produce a light N from a light N enc, what we need to do is we need to scale it and bias it. So it's 0 to 1 right now, so we need to, again, multiply it out by 2. Then we need to subtract what is effectively the midpoint now, right? So it's going from 0 to 1. We need to like bias it out to 0 to 2 and then shift it down to get it to be negative 1 to 1. So we can do that, and now we'll get normals out that are full range, but hey, guess what? We're not packing them at full range yet. So we need to first shift them up when we actually plug them into the shader, the OpenGL system in the first place. So when we go to our lighting encode, right like this, we need to actually do the encode here, right? So the irradiance pack, like we have here, we now need a normal pack, right? Oops. And we need this pack to just shift up. And you know, we don't really need to call it we could just put it like binormal. Do we actually already have something like this? Like binormal to something. Not really, no. So we need like a binormal pack here. Something like that. Right? And so then we can have a function that, much like our irradiance pack there, where we've got something that takes in an n value and produces a result value that is the scaled and biased version of this thing, right? Something like this. So we basically like we halve the value and then shift it up so we know that it's between 0 and 1, right? And it's just the inverse operation of what we like did in the shader. That's it. So now, hopefully, our normal encoding is working correctly, and it does look like it is now, right? You can see that as we move the light so that those faces are back-facing to the light, they get no light, which is what that's what this test sphere is designed to do, give us exact, reproducible things we can test. It does seem like that to me. It's working on all the different kinds of faces, it looks like, that looks pretty convincing. So I think we're packing those down properly now. Let's do a quick test here. If I want to spam in another value, so in here where I've got the N lighting computation, where we're spamming in test lighting values, if I want to produce some sort of a secondary light source, so you can see here like how this nonsense is working, right? You've got the light and the light distance, right? That stuff happening for the first light. And so if we wanted to do this for more than one light, right? Like we wanted to have a couple different lights that get placed in here. What I would need is some idea of where the other light actually is, right? And so I would need, a second light source. I don't know where that should be, but what you could imagine is like, let's suppose I create a light 2 UVW here. And I guess honestly, like, maybe we do this with a for loop or something. Nah, I won't bother. So here, we put the light P in. If I wanted to have a second light P, I could say that light P2 equals light P plus some fixed offset. So let's suppose I want another light source that's just like always 3 meters to the other side or something, right? Maybe that's not enough. Like, let's talk about 5 meters. I don't know. So supposing I wanted to move the light source 5 meters away in the x direction, we'll just try that. And maybe we say like, okay, we're gonna, excuse me. We're going to compute that now. So I'm going to take this snippet of code, which is just like a little like reproducible snippet. Again, I'm just doing test code here. Ordinarily, if I thought I was actually going to do this a lot, I'd actually pull that out into a function probably. I'm not going to bother right now. I'm just going to leave it in here. And what I'm going to do is, since we now have a light 2 UV, you can see that there. Why is this? I don't even know why that's not just that. Don't ask me. But I'm now going to switch to using the second light. So now we have a secondary light here, and you can see that we're like computing that light source differently. All I'm going to do is I'm just going to switch it to having that second light go out on the second channel. And so all I want to see here is if that will actually work at all, and just kind of start to like massage that into place, right? So now we should have 2 lights, and you can see that they are actually both where they should be, it looks like. So now we've created kind of a blob with the other light kind of separated from this light. And in theory, right, I should be able to separate them even more if I want to. So if I came in here and I wanted to look a little bit more closely at that shape, you know, let's say I spread it out by 10 now, and we wait for that recompile, reload. We should see that jump to the side. Yeah. And maybe like a little bit more like that. So I can see the interference pattern between the 2 lights. Where they start and stop and that stuff, right? So you can see that looks pretty reasonable there, right? Now let's get them overlap a little more. I'm going to change the color values here. So we've got 2 different colors values. Maybe I will drop the blue, so we got a yellow light, and drop the red, so we have a cyan light as well. So we can just kind of see the colored regions of these 2, which should, you know, hopefully interpolate properly as well. So there's our 2, right, separate color lights that we're reconstructing there. And then what I'm going to do is like smush those together. So now the light separation, let's make that more like 8. So there'll be an overlap region, and it should be like white-ish in the overlap region because you've got 2 light sources that are combining there in theory. And, you know, it sort of is, right? It's more white anyway, right? And of course, since these 2 lights are actually in different places, what should happen as I rotate around too is I should see some play of the light, and I do, which is good, right? Because there is a little bit of specular on these surfaces. Now, I could really crank that up too. Like if we wanted to, we could take a look at what happens with the specular a little bit more. But you can see, like, you see how you're getting that specular on there a little bit, right? You see it? And that's kind of a nice effect too. Again, not something we're really going to lean into in this particular game, but, you know, it's nice to have a little bit of specular option in there for just getting a little bit of that. It just adds a little character to the lighting. You know, it's great if you want to go full bore and have actual like reflective surfaces and stuff like that. Yeah, that's awesome too. We're not really looking for that here. We're not looking to solve that particular problem. But in this case, we do get a little bit of that character in there. And adding a little bit of specular character to a light can be useful. All right. So I think this is looking great. And to me, that just says, yeah, like, I think this has a lot of potential. So now the question is, how do we get from light probes to this in a reasonable way, right? And I do think, you know, I mean, one thing is we probably have too many light probes. I mean, just looking at how many there are, it's like, do we really need that many light probes? And the answer is probably no. But we're going to stick with that many for now, and then we'll just like start to decrease the number of light probes that we have as necessary, right? And we'll start to work with that a little bit differently. But I guess what I would say is, you know, as a light sampling scheme, I think this is pretty good. If you get more than 3 lights, and, you know, again, we could also just crank that up to 4 lights, and I don't think we would see a lot of problems, right? If we have to actually like have a way to turn off lighting on the profiler, which we haven't done yet. Like our profiler is still being lit, unfortunately. Not exactly what we want, to be sure, but you know, that's just you know, how graphics goes sometimes, right? Everything's going through the same pipeline at the moment, and we just don't have a flag for that, so we're gonna have to do that at some point. Not my fault. That's just how things go, right? But anyway, looking in general at the speed, though, if I was to fire up Nsight here and just ask it to tell me how bad is this situation in terms of speed there, right? So if I grab our, you know, our project and ask it to launch the frame profiler, you know, like what, NVIDIA, what do you see, right? And, looking at this graphics card, it's eating that for breakfast. Like that 3 voxel samples, it's just like laughing at and telling me that it doesn't care at all. Or 3 pairs of voxel samples. So, it means we could really decompose this into a large number of these things, I think, and not really have to worry that much about it. So we could probably even go to 4 light channels and not really break a sweat, right? Because 160 frames per second is way more than the number of frames per second than I felt like I needed. That's way over the spec that I demanded this game be at. And so I'm okay with that, right? So if we wanted to crank that up and just say, let's have a lot of these, right? Maybe I just say, like, let's have 4 lights total we can blend between. And that's just a crazy... Because remember, this is like every voxel can capture 4 incoming light directions, which is probably like way overkill. But I just want to see if we can do it. Right? I just want to see if that has really any problems for us whatsoever. So let's say we've got a bunch of these here, and I just want to do like this, right? So we've got like some stuff, and it's happening, and whatever. And if I create 3 dependent light sources off of the 1 light source there, I stuff them in here, and I give them some other, color characteristics. So maybe we've actually got like a red and a green and a blue light there that are separate, and then here I've got some other light, maybe like a dimmer sort of white light or something, or maybe that's just a pure white light. I don't know. I don't care. So we've got some lights in there, red, green, and blue, and now I just want to stuff those lights into the system. So when we come through here, we're just going to do like, all right, here's our 4 light directions. That's how many you get. So, hopefully you can encode whatever complex light field you want with somehow decomposing it into 4 light directions, which is, or someday we switch again to some other encoding spherical harmonics. I don't know what. But, whatever we think of, whatever we end up thinking is right, we encode, right? So we've got the light directions here. We switch the light direction count here to 4. We recompile and cross our fingers. I don't know if there's anywhere else that it matters, to be honest. Might not. And then we see if we can make that happen in a useful way. All right, so here's our lights. If we zoom out, I guess I don't see my 3rd light, which makes me a little concerned, right? So I've got the 3 lights, but I don't see the 4th, even though the light direction count is ostensibly 4. Looking at our 4 UVWs here, did I forget? 3, 2, 0. I didn't. 0, 1, 2, 3. 0, 1, 2, 3. Sure seems like... Oh, yeah. Hey, man. You've got to actually load it in the shader. That's the one thing that's not based on arrays here. I haven't been using arrays in the shaders. You actually can. I'm nervous about it because I don't know what kind of OpenGL3 compatibility there are to arrays of samplers. So it's really just a fear. It's really just a fear-based thing is the reason we're not doing it. You absolutely could have done that. And so it's just kind of no real reason. So I apologize for that. I'm just not willing to go down that spelunking path at the immediate moment. But that there's no reason we couldn't have made that be something in the shader that was just parameterized as well. We just are a little worried about it. All right. Oops. Forgot one more thing. There we go. So in theory now we should have bound all of our textures up, and yeah, and hopefully we'll get our 4 lights now. Looks good, right? So there's our 4 lights. They seem pretty good. They look like they're in the right places. Not seeing anything particularly odd going on there. Looks good, right? And so I think that should be fine. If you look at what's happening to the lights right now, you can see they're already fairly complicated. Like, you're getting fairly complicated effects from them. You can see that nice specular character. You see how the red light kind of plays off a little bit there, right? And you get a little bit of a shifting of the highlight. So I think we're in good shape. And I guess that's good enough for me, right? I'm willing to say, great. Ship it. Now we just need a way of putting light information into here. That's going to be good. We've got a few minutes left, so maybe let's start down that road. We can now go ahead and actually say let's output the probes, right? And the probe output is totally borked right now because we now need some we need some way, and this again this is going to be the hard part now. We need some way of taking our probes and dumping probes down into the voxel in some way that makes any sense whatsoever, right? And there's a lot of ways we could do this, but I think probably fundamentally speaking, this is maybe not a very good way to do it, because since we're trying to do reconstructing of light fields here, I don't really think we may more want to loop over the probes themselves and sum them into the voxel, as opposed to doing it this way, which is using the closest voxel, the closest probe to the voxel to fill that voxel. So I don't really know that this makes a lot of sense. Like, the way that this particular thing is working doesn't strike me as particularly intelligent. Really anyway. So I don't know that we really want that, right? And so we're probably going to want to make this be a little bit more what we're going to want to do here is say, all right, the light probes are just things that store lighting information over time, and they're the locations at which we try to compute what the light field is, right? But what we're fundamentally doing now is, now that we sort of know, well, we can use these fairly cheap trilinear voxel lookups to actually capture lighting information pretty well, it seems. What we're trying to do now is say, how do we separate, how do we actually track and separate light into 4 components whose directions can vary arbitrarily, right? And again, this may be stupid. It may be that we should just use spherical harmonics or something, right? But the reason I'm just not sure about them is I just don't know how their behavior as a signed distance field would actually work out. I suspect that if I were actually doing this on my own time and could spend, 80 hours this week just diving into this and trying all kinds of crazy stuff, what I would first probably try to do is figure out if there's a version of a spherical harmonics encoding that can work with a signed distance field. Because that's probably what you want, right? In this particular case, I don't actually know exactly how I'm going to do something here where we have to actually track directions. And that's why I think that maybe the other way to do it would be interesting. But in the absence of that, we're going to have to make something up. Because we don't have 80 hours to spend. 80 hours, to put that in perspective, would be probably another 20% of the entire time of Handmade Hero so far, or something like that. Right? Handmade Hero, despite having a day number, that's really more like an hour number or half an hour number. So you're talking about 1,000 hours we probably spent on Handmade Hero is all that's total time. So the amount of work I would do in 2 weeks of exploration of something could be, 1/10 of the entire time we spent on Handmade Hero so far. Just to put in perspective how limited a resource we actually have, time actually is on Handmade Hero. We just don't get much time, right? And so, that's just a limitation of the streaming format. It doesn't really work that way, right? So what I want to do here is start to figure out, what are we going to do? How are we going to make this stuff make sense? What's going to happen? And so if you think about what's going on, we effectively have sort of a we are going to be tracking lights that we see in the world using raycasting, right? And so all we're going to know when we get back a raycast is we're just going to have a thing that says, well, we kind of know that in this direction we saw a light that was this bright. Like we saw lighting coming in that was this much lighting. And so if you sort of imagine how we're going to track that information, the question becomes, well, what is the thing that allows us to just over time sum lights together, but that we can then reconstruct a lighting field from it in some way? And I really just don't know, right? Like I don't have an idea of how to do that. One way might be, and maybe this is something we should start with because, hey, it would give us a way of transitioning later. But one way might be to say, well, on the CPU side, maybe our light probes just store spherical harmonics exactly, since they don't have to be interpolated, really, right? And then what we do is we just extract the top N lights from those spherical harmonics and put those down as the light field, right? And then if later we decided we actually want to just interpolate spherical harmonics directly in the actual shader from the samples instead, because we figure out we can actually do that without the artifacts, which I'm not sure we can, but let's say we could, then we're in good shape to do that because what we're actually tracking is spherical harmonics, so it's not so hard anymore to like make that work, right? I don't know, right? I wish I had the answer. I'm not sure. We're more or less out of time, so I probably won't really do anything here because I'm not even sure what I would necessarily do. So I guess I'll leave this on Sphere, and we'll go to the Q&A, and then we're gonna have to think like next weekend. That'll be kind of what we need to figure out, right? Like what are we actually doing, right? Like what will be the strategy there? Now that we know it's pretty easy to reconstruct light fields from voxels, you know, it's pretty interesting, right? And I mean, it's worth kind of noting that, like, at this point too, another thing is you know, let's say you had lots and lots of light sources in there, and you just wanted them radial. You could actually simulate lots of, like, you know, you could simulate 100 radial light sources with just this lookup scheme, without changing the number of voxels, because you just use the 4 brightest ones at any given point, right? So yeah, I'm chuffed to bits, as they say. I just now need to think about how I want to like dump the information down to the sampler, and you know, maybe make some changes to the sampler as we go, based on what the right values to interpolate actually are. Another interesting possibility here, as I'm thinking it through as well, is, you know, the way that this is being coding, you could also think of the color channel as being a separate thing. Like we could track colors differently from the way that we track intensities, because the eye is more sensitive to intensities than color. And so if the color was more of a wash, but the intensities is the thing that's actually getting interpolated by scientific films, that may make it easier for us, because then we could we could play it a little faster and looser when we're actually at summation time. So it'll be interesting to see, but I'm pretty pleased. All right, let's go ahead and go to Q&A. Have you taken anything you implemented in Handmade Hero and used it in your other work? No, not yet. But I probably will take the PNG stuff we did and move that over to my own little PNG. Like, I'll probably optimize it and make a little PNG file that I use. Because right now, like, I mostly only do Photoshop I/O. And it would be nice to have a PNG I/O as well. So PNG IO might be something I steal because I'd never implemented one of those, and we implemented that on stream and that went really well. And now that I have a reference code for it, I could make a nice fast one and leave it at that, right? What are you working on during the week? Well, I am the only programmer at Molly Rocket, so we have several projects. This one is one of them. There's one that's unannounced, and then of course we also do this one. Although my involvement in this one is limited, so that's what I work on during the week. But you can also go here for sort of our general news and just information about our projects tends to be up on here. Also, the other thing you can do is if you click this button, it's kind of a little hidden feature. If you click the head at the top of any Molly Rocket page, you can get all the other Molly Rocket pages, right? So it's pretty easy to link them together and jump around. So like on Handmade Hero, right, you can get to Meow the Infinite. And if you got Meow the Infinite, you can get to 1935, right? You can get to Anna Draws It. You can get to my blog. So it's pretty easy. How will walls stop light? Same bouncing rays as before. Yeah, pretty much. So the main thing that we have to do now, and it's the part that I'm not sure how we're going to do it exactly. So I like the sampling. It's interesting, but we may need to play around a little bit. The main thing we need to do now is, so now we re-enable the raycaster, right, which we wrote, and that will tell us how the light moves around the scene. But the problem is we have to figure out how to translate a ray tracing input into a trilinearly reconstructible set of light fields, right? And that is the thing that I don't know, exactly how we will do, right? I may do something really nutso first, right? So I assume there's a source of income not working on projects for pay. Well, we have some limited sources of income, but we're also funded through basically 1935's completion. But we have to pay that back, right? So we may just disappear and be out of business after that if our games don't make some money back. So who knows? But we do have some limited sources of income as well. For example, Handmade Hero purchases is income. It's not much, but it's something. And so on. But yeah, until our actual games start coming out and are purchasable, it's hard to know if we'll be successful and still exist. Similarly, Meow the Infinite, I think it's actually a really good comic, to be completely honest. I know I'm biased because obviously I wouldn't have greenlit it if I didn't think it was cool. But I think as it gets a little more established to it and you can buy an actual bound book of it, I think it'll be pretty popular too. It's already pretty popular with kids actually, and it's kind of an all ages thing. I don't know. I think it's pretty good. And I think as it gets further along, it kind of becomes more clear that it's actually pretty interesting, is what I would say. So I think that'll also make some money too. But anything that's like a comic like that tells kind of a story, it kind of has to get to the point where it's actually more complete. And furthermore, people don't really like reading comics online. The only kind of comics they like to read online are like Dilbert kind of things, or like the Oatmeal or XKCD, where they're kind of they're not really like a story. They're like social commentary or something, where you just read one page and that's it. So we don't really know how successful that project will be either, because we'll have to see what happens when we actually take it to some cons and have a printed volume. Be like, here's book one. We'll have to see whether people like it, right? So I think that might make some money as well. So we do have some limited income now, but we'll really only know what our income situation is after 1935 and our unannounced project are available and selling, and whether anyone buys them, right? I hope they do. At East Utrecht, you do realize you could be a very wealthy man if you accept a small project for a few weeks, right? Not really. At least not that I know of. I have had, pretty good consulting rates in the past, certainly. But one of the problems with running a company in the U.S., especially in a place like Seattle, or heaven help you, like I shed emotional tears for John Blow like every day inside a little bit, running a company in San Francisco, right? It's just like, oh my God. The cost of living and the cost of employees here or contractor work is like astronomical, And so the problem is that you're talking about making a game, you're looking at like $1 million or something of cost to make a game. If you want it to be like a serious game, like that's good and has good art on it and stuff like that. If you're in these areas, it's very expensive, right? And it varies by region dramatically, right? Like the cost to make a game in San Francisco, where you're talking about people working, actual employees working in San Francisco, the cost to make a game in San Francisco versus the cost to make a game in Croatia versus the cost to make a game in Argentina or whatever, right? Is very different. And it's not because the people are better, right? It's just the cost of that area, right? Because there are great developers in other parts of the world. They just happen to live in places that are a lot lower cost of living, right? And so I guess all I would say is there's not much I can do as an individual taking a project for a month or two that would pay me enough money that it would matter to the success of the company, right? No one's going to pay me like $5 million to do a 3-month project. If you are, please email me, right? But no one's going to do that, right? You can make a ton of money in like a jackpot fashion by like doing something like working for a startup company and getting a lot of stock, right? And like cashing out or something like that, right? But realistically, if you're just talking about contract programming, I don't know of anywhere where you can get like literally millions of dollars for short-term work. And the reality of the situation is that trying to make games in high-priced regions, you're talking about money on that scale. And it sucks. It does. But, sometimes you just get unlucky and that's where you live, right? And maybe we should all move to Montana, and we probably should. I don't know why we're still sticking around, right? But we could all move to Montana, and for the same amount that you're paying every month in rent in Seattle or San Francisco, you could own, the state of Montana, right? And so I think, like, to a large extent, there's a lot of disparity, and it's just because, web companies and stuff generate an unfair amount of money, largely due to the fact that they have an unfair playing field. At the risk of a long digression into economics, most of the reason why we have these incredible wealth concentrations in a few places is pretty much just 100% unfair competition, right? Period. And the reason I say that is because if you look at a company like, for example, Facebook, and you're like, how is it that this company is able to be so wealthy? the answer is very simple. They are exempt from most of the laws that other people had to actually obey. That's why. If they actually had to follow copyright law, they would be out of business already. The number of lawsuits they would have had to settle for copyright infringement alone, Facebook wouldn't exist, right? And so you look at a lot of the reasons why web companies exist at all, it's because of unfair competition. They haven't had to comply with the same laws that all existing companies have had to comply with. And that's really why they're wealthy. It's no surprise when you have people who can basically, not have any regulation, that they beat a bunch of companies that have to be regulated, right? And that's just the way it works. So there's not much you can really do about that. And eventually that won't be true, because this is always the progress of industry. In the old days, there used to be things called company towns in the US, for example, right? A company owned a town. They ran the post office. They were the governor, right? Or the mayor, right? They supplied the police effectively, right? They made the law. That's what happens at the start of a new type of industry, when they are settling something. Eventually, and the wealth concentration is phenomenal, right? This is what happened in the settling of the United States as well, right? And that is because it is largely lawless, right? It has not been reined in and people are doing whatever they want. You know what I'm saying? That's what happened with technology, right? That's what happened with the internet. And eventually, people don't probably appreciate it as much, but that's what will happen to the internet as well. So governments are now regulating it like crazy. GDPR is a very good example of the EU saying, you know what, we've got a bunch of rules we're going to impose. The EU is thinking of imposing rules like click wrappings rules and stuff, like you have to pay if you link to things, right? And what that is it's not unusual, and it's not government overreach or anything like that any more than any of these other things are. What it is government eventually moves in to regulate things once they are important and once they're valuable, right? And once those laws arrive, all of this stuff normalizes out, right? Because now it's a level playing field, and the government wants their take, and the government takes control, and it's no longer a giant party where you are the government and you take all the taxes, right? So that's really what we've seen. And for people who are either, you could argue, lucky enough, or maybe you want to say unlucky enough to live in the centers where these effectively lawless corporations have been occupying the physical real estate, well, big surprise, everything is incredibly expensive because they have effectively unlimited money because they have been able to conduct business outside of any regulations. And as you might expect, anything unregulated beats things that are regulated, and that's where the money moves, right? So for those of us who live in Seattle or San Francisco or a couple other places that are similar, what ends up happening is, you have to rise with those rates, and there's nothing you can really do about it. You can move away if you want to, and that's certainly an option. It's an option I would consider, right? Or you can stay, and you have to basically be really competitive, and you have to be much better than you would have to otherwise be, right? Facts of life. This is just how the world works. There's no sense crying about it. It's just how it is. And so I moved to Seattle in 1995. My first apartment cost $495 a month, and it was totally fine. Wasn't a nice place, but it wasn't even on the ground floor. It was a third floor apartment for $495 a month. That same apartment probably now costs at least $1,800 a month, would be my guess. And I doubt it's been renovated at all. Right, but it's exactly the same. And so, I never left. So I'm stuck with it. That's just the way it is. Now, it's worth noting that it benefited me, though, because during the time that I did work in industry, I was able to stockpile some money. So some of the stuff we did at Molly Rocket, I bankrolled myself, right? Because I had some money. And the reason I was able to get that money was specifically because I was in an area that effectively overpays me, right? Like I can work on projects that pay me a lot more, and I know the people, and I'm in the area, right? And so, it does benefit me a little bit. If I choose to go to work, it benefits me greatly. But the problem is when you then go to try and do projects independently, they're small in scale, that aren't operating in the same kind of lawless space, that don't really have much benefit. They don't get a lot of benefit from deregulation. Games don't really benefit hugely from deregulation the way that web services do. You gotta take the good with the bad, right? So sorry for that long discussion of it, but that's the truth, right? That's just how the world works, and there's nothing you can do about it as an individual. Maybe collectively you can do things about it, right? Because you vote for your government, or you participate in some kind of fora that shapes the public thinking about these things, or who knows what, right? So maybe you can do things about it, who knows? But, absent doing something about it, you have to kind of just play along with the way that things are structured, right? It's just something you have to do. In terms of programming techniques, how has your style changed in the course of this project? Are there things you did at the beginning of this project that you think were steps in the wrong direction or would do differently? Well, we've corrected most of our mistakes on Handmade Hero, and that was the goal. I wanted to show how you correct those things. There definitely are a few things. So the biggest thing I would say, the biggest difference is when I started Handmade Hero, I had very little multi-thread programming experience, and very little out-of-order CPU optimization experience. I now have a lot more of both of those. And so the sections that we did on those were poor. If I was doing multi-threading or out-of-order optimization stuff today, it would have been a lot better. I just know like way more. And so those were pretty poor. They don't matter a huge amount to this particular project, but that was the case. And the other thing is, I would say the debug system, we overcomplicated it too much. Or just, I shouldn't say overcomplicated it. We complicated it too much. And we should have stuck with simpler, more purpose-built things. So that could be simplified now, I think. Other than that, I think we're roughly, I was happy with most stuff. And I was happy with those things too. I mean, the goal of Handmade Hero was to show, what's realistic for a programmer to be doing. There's supposed to be mistakes. There's supposed to be areas that they don't know about, because nobody knows everything. I mean, there are no programmers who just know how to make everything perfectly every time, right? That just doesn't exist. And so I want people to have a very realistic expectation. I don't think I would have trouble getting hired at a game engine company pretty much anywhere at this point in my career. But as you see on Handmade Hero, I have questions about stuff all the time, right? I'm always like, I wonder about this, or I would like to talk to an expert in blah because I don't know, right? And I want people to understand that that is the standard, even at a pretty far along point in someone's game development career. You do not know everything, and you never will. I don't care who you pick, they don't, right? And so, having a realistic expectation of what you're supposed to be able to do, best case, was important to me. And it's important that people see that on Handmade Hero. I want them to see me make mistakes. I want them to see me have to debug things. I want them to see me have to change my mind. Because to me, that's like the value, is having a realistic portrayal of what it's like to program. Not a sort of aggrandized, heroic version where I already know what I'm going to do exactly on stream and then just magically do it and it all works, right? Because to me, that's sending a very incorrect message about what you should be able to do and what you shouldn't be able to do when you are a game engine developer who, is established, right? When you're past the novice stage. And so hopefully, we've captured that on Handmade Hero pretty well. And hopefully people feel comfortable with making mistakes and not knowing everything and asking other people or expecting that there will be people who know things that you don't. And to not feel like that's something that goes away, to not feel like that's something that only happens because you're a beginner, right? And so... Can memory fragmentation happen on a GPU? Well, gosh, that's a really tricky question, and I guess not one I'm prepared to answer. So I apologize. The reason that I'm hesitant to answer that question is because obviously any piece of hardware that has a memory system in it can have fragmentation problems. That's just obviously the case, right? But the intervening factor that you get with a GPU is that 99.9% of all of the code that goes to a GPU is using some degree of blind handles, right? So if you imagine, for example, in OpenGL, which admittedly is a bit high level compared to something like Vulkan or D3D12, but let's suppose you just looked at what would happen with an OpenGL app. Well, you'll notice that all of our textures are described to the GPU in what way? Handles, right? So when we say we're trying to draw this, thing to the screen, it's texture number 37. We're not talking about memory. We're just talking about a slot, an abstract slot, right? What that means is that it is relatively inexpensive for a driver to do memory compaction behind our back. We don't know where slot 37's data lives. Could be anywhere. We talk about it on frame 3. Maybe it translates slot 37 to one chunk of memory. We talk about it on frame 97. It's moved it, right? Could have easily moved it. We have no idea. So I guess what I would say is that probably GPUs probably don't have as much of a problem with memory fragmentation as they otherwise would, because a large number of the things that use them and interface with them don't actually know where the things they've allocated are, which allows the driver pretty much carte blanche to rearrange them. Now, the reason I'm hesitant to just say, well, so there's no problem with fragmentation on a GPU because the driver could just fix it, is because, again, the flip side is also true. For example, bindless textures are a good example of not really possibly being able to do remapping. The overall effect there is that certain lower level access to the GPU that is actively encouraged by NVIDIA and AMD and whatnot does start to expose the actual location of things. And once that's true, the graphics card will have a harder time managing the fragmentation. Now, it's still not a given that you have a fragmentation problem, because in order to have a memory fragmentation problem, you have to be looking at memory holes that happen at a granularity that isn't at the virtual page size of this card if it has memory mapping itself, right? And I guess I don't know the specifics of those sorts of things, right? So all I can really tell you is, yes, fragmentation can be a problem anytime you have unpredictable memory allocation and deallocation patterns. No, the GPU does not have as hard a problem perhaps as other people because of the way the APIs are designed. But yes, it still could happen because some of those APIs do expose details that may be low level enough to create a problem. Hopefully that helps. And yes, these pants are very comfy. How would you compare WinDBG and RemedyBG? Should I consider switching to Remedy if I'm using WinDBG? Yes, you absolutely should consider switching. I would compare them as such. I would say WinDBG is like 10 out of 10 on features and like 0 out of 10 on usability, right? It has like every feature under the sun. Most of the features WinDBG has, I probably don't even know about. Like, I mean, there's a huge array of command line options and plugins and all. Like, the number of debug features WinDBG has is insane, right? Remedy has, like, by comparison, very few features. Like, the number of features in RemedyBG is pretty low compared to WinDBG. That's true. But the usability is like 10 out of 10, right? So what I do, and what I would encourage you to do, buy a copy of Remedy, use it as much as you can. When you get to something that you can't debug with Remedy, begrudgingly downshift to WinDBG, right? That's what I do. Because the day-to-day debugging that you do doesn't require most of the features of WinDBG, so you're just suffering with a horrible user interface for no reason. Why not let Remedy upgrade that experience for you, right? And it takes 10 seconds to launch another debugger if on the particular days when you need to actually address that problem, right? When you need to, like, oh, there's a particular feature, I need to download symbols from Windows Symbol Server and step through a thing and do a mini dump and blah, blah, right? When you start to use all, like, tons of debug features there that need to get, like, when you need to sort of get, like, a power user debugger interface, then, it takes 10 seconds to fire up WinDBG. Just go ahead and do it. But the rest of the time, I would use Remedy, right? And that's my opinion on it. And that's what I actually do. I don't find myself needing WinDBG hardly ever. Weeks will often go by before I need to switch to it. But your mileage may vary, right? Because it depends a lot on the kind of debugging you do and what you need. RemedyBG is also always improving. It's better this month than it was last month, right? And so the other thing I would say is, if it doesn't work for you right now, because you try it and you're just like, doesn't have enough features, I need X, Y, and Z. Make sure you file them on the WinDBG, the RemedyBG GitHub. There's a feature request GitHub. Make sure you file what you need on there, and then come back and check in 6 months, right? The upgrades are free so far. So, you pay your $20 or whatever it is, and, when it's ready for you. So yeah, that's my take on it. But you have to make your own decision. So. Where can I learn more about out-of-order optimization? I don't know. Sorry. Could you explain the stripped binary? Is it possible to optimize a binary even if there's no access to the source code? Sure. I don't know what you mean by stripped binary. There's a couple things that could mean, so I can't really explain a stripped binary because I'm just not sure what stripped binary means. A binary is a binary, and if maybe you're talking about a binary that doesn't still have debug information with it or something, I don't know. But in terms of whether it's possible to optimize a binary if there's no access to the source code, yes, it certainly is. There's a lot of techniques you can use to do that, but there's some pretty easy ways. So the easiest way by far to optimize a stripped binary, at least, and again, I'm not a reverse engineer, so this may not even be the easiest way. Take it with a grain of salt. But a very easy way to optimize a stripped binary is to just relocate functions, right? So for example, if you have a particular code path, it issues a call, right? So there's a call instruction that calls out to a function. Any call site like that, you can usually optimize that by calling somewhere else. So what you can do is take whatever the function was that it's calling, write a more optimal version, link it in, place it somewhere in the executable, and jump there instead of jumping where they were jumping, right? And that's a pretty obvious way. Another way a lot of people do it is they'll just patch over some part of a function with a jump call that jumps somewhere else and then returns there, right? It's all kinds of stuff like that. Do you have any resources on why OOP programming isn't that good? I mean, nothing definitive. I would like there to be something more definitive, but even recently on Twitter, I tried to ask for people to just do the opposite. Like, do you have any resources on why OOP programming is good? And I didn't even really get any answers. There was literally 100 replies, and most of them were disagreeing with each other, right? So I don't even know what people claim is good about OOP. So it's hard to say why it's bad when you don't even know what you're talking about, right? And so I find the whole situation frustrating, and I'm just disinclined to even engage with it. It's like, if you want to program in OOP, go right ahead. Just don't bother me about it, right? What would be the best way to prevent overdraw in a software rasterizer, in particular with a voxel scene like Minecraft? I asked this before, but didn't specify the type of game. Well, most of the time what you're talking about with preventing overdraw is you're just trying to figure out ahead of time how you can draw front to back and know that you don't need to draw anything else, right? So typically what you do in something where, for example, Minecraft, typically what you would do in a game like that is you would pre-process, and I don't mean pre at load time. I mean pre as in before in the middle of a frame or during the run of the game, right? You would take large sections of the voxel and you would find solid regions of them, right? And then when you're doing your rendering, as you render, you would probably want to sweep from the front backwards. So as you go, right? And you can do two things. One is you can lean on those large voxel clusters that you've built into maybe larger cube, rectangular occluders, to just frustum cull the projection of that against the whole voxel world, and no, you don't even need to consider anything in that area. So you don't even process that part of the voxel, right? And then the other thing you do is as you go forwards, you keep track of some resolution on the screen, let's say 16 by 16 squares, and you just keep track of whether you've drawn them or not. And so if you progress from front to back, which you can easily do in a voxel world, what you do is you just go, when I'm about to rasterize, if I've already drawn everything in this 16 by 16 block, I just no longer even ever rasterize anything in it. I just early out any pixel block that's in there, right? I've heard you mention before that you don't like callbacks. Should they be avoided at all costs? How would you avoid them if using recursion and navigating a tree-like structure? Yeah, I mean, I don't like callbacks typically because I find that they make it very hard to use the code that's involved. Part of that is because C and C++ are bad at closure kind of things. They tried to improve C++'s handling of that, and they've made some improvements, but mostly it's still bad. So a lot of it is because of that. But in terms of avoiding them at all costs, no. I mean, if you can't turn something into an iterator for some reason, and you really feel like you need a callback, then sure, you can use one, but they just have a high cost, so don't do that unless you're really sure that the alternatives are really bad, right? Is what I would say. What's your opinion on whiteboard interviews in the big tech companies like Google? I think they're stupid. I've said this before. Assuming you're talking about a whiteboard interview, I give you a programming problem and you solve it on a whiteboard, I think they're dumb. I think what you get out of whiteboard interviews is kind of exactly what you have at Google in terms of the common case employee, which is to say people who are smart on their feet but probably aren't very good programmers. And I think that's mostly what you get, right? Now, you may get good programmers who happen to come through that process anyway, if they are also smart on their feet. But you're not really screening for the thing you need, which is good programmers, because, programmers don't work on a whiteboard. That's just not how you write code. So, I don't think they're very useful. I think they screen out people who have maybe poor social skills or who have trouble communicating. And I know that places like Google are always like, no, we want good communicators. And stuff like, no, you don't. Like, no. Like, the people who have written some of the best software in history are terrible communicators. You don't want to screen them out. And why do you even have managers if you can't deal with people like that? Like, again, it's a really backwards and counter to the history of computing, like, way of thinking about computing. It really kind of disgusts me. It's like the new kind of way that people try to claim is good to build computing companies. And I think the proof is in the pudding. Google products are terrible. I mean, they get worse every week. It takes multiple minutes for me to use Google Drive now. Like, I have a directory in Google Drive that has 800, right? Shocking, 800 files in it. 800 total files, right? 800, that's the number, not even 1,000. It takes something like 30 seconds to produce a listing, and the listing is wrong. It's not done yet. So, you ask for a sorted listing A to Z, and it's missing a bunch of stuff. And then, like, a minute later, those things show up, right? That's the engineering, right? And so, I don't think they have anything to tout, in my opinion, right? I think the pudding is pretty rotten that comes out of these companies. So, I don't think they can speak highly of their interviewing process, or if maybe their interviewing process is good, then maybe their managerial process is bad. I don't know, but they produce very low quality software, like extremely low quality, I would consider it. About as low a quality as you can get, and still say that it's a product. I don't know. Like, it's very, very bad, right? So many questions today. I gotta go. I'm getting hungry. If virtual memory exists, how are games still able to be hacked? Is it because offsets are constant? I guess I'm not sure I understand the question exactly, but you just mean, how do you modify a binary if you have virtual memory, or? I don't understand the question, I'm sorry. Have you heard about Game Development Workshop Assembly and also Assembly Archive? No, I don't think I know what that is. Is there an errata page for the Jeff and Casey show that I can submit to? Probably not, but you can send it to podcast@jeffandcaseyshow.com. The Horse One's Brown asked, how do you design memory arenas for multiple dynamic arrays to please the cache? I'll be honest, I don't like dynamic arrays for exactly that reason. I find that dynamic arrays don't really lend themselves well to cache coherency over time in that way. And I find that they also make it hard to manage your memory properly to avoid fragmentation and stuff like that. So I'm not a fan. I'm not a huge fan. So I pretty much never use dynamic arrays, pretty much ever. So I guess I can't really answer because I don't have a lot of strong opinions about that. Don't you think the reason for low quality software was because people wanted to do things faster? I don't know. I don't know what the reason is for low quality software. It can't be speed because Google's got so many employees. It should be possible to ship a reasonable software product. I don't know. I don't know why web companies produce such low quality software. I have no idea. I would like to express my deepest disappointment in lack of new JNC episodes. Yeah, sorry about that. We'll try to fix that sometime. The horse's brand. I mean, for software for simulation, something like Mathematica. I don't know. I don't know what you mean, sorry. Shocker 93, do you think it's possible to turn web around? I mean, it probably will sort itself out eventually. I mean, if people ever have the ability to compete, I don't know. I mean, one of the problems is it's too many bundled services that come together. It's very hard to disaggregate. Like maybe you make a better messenger than Facebook Messenger, but can you really compete with Facebook Messenger because everyone's already on Facebook, right? Things like this. I don't know to what extent competition will solve the problem, but it's obvious that like pretty much all of these companies, you could easily make a product that's better than the product. I just don't know to what extent you can succeed in the market by making a better product. Making a better product than Google Drive would be like trivial. I mean, it's absolutely horrible. Um, uh, but I don't know. I don't know how hard it is to compete. I don't know. It's not my industry. If you're an employer, which candidate would you choose? 4.0 GPA with no side project, 2.5 GPA with lots of side projects. So, in my experience, I wouldn't care at all about a GPA. Things I don't care about: GPA, what college you went to, unless it was Harvard, in which case I might just mark you down as a negative. But assuming that it was not Harvard. And like probably like whiteboard interview skills, right? Don't care about any of those three. I would want to see projects. I want to see what you've done, and I want to interview you and ask you about those projects at a deep level and see how well you're able to actually convince me that you know them. And I try to do that in a way that's very comfortable so that you're not stressed and it doesn't feel like I'm pressuring you. I'm never going to ask you to solve a problem that you're unfamiliar with. And that's really crucial, right? Because what I'm interested to know is, given the time that you've already spent on something, did you solve the problems then, right? And did you internalize the knowledge then? That's what I want to know, because that's what you're going to do when you work for me. I'm never going to come to you in the middle of the frickin' day and be like, hey, Bob, or whatever, can you solve this problem on the whiteboard right now? Like that's not a thing. And any problem that's solvable on a whiteboard in 30 minutes is a problem we've already solved in computer science. So it doesn't matter, right? The things I need you to solve take weeks of thought. And the work I want you to do is typing in a lot of code that works. It's not on a whiteboard. It doesn't have to do with getting a slightly faster string sort that doesn't loop through the array twice, or whatever stupid idea the Google engineer asked you to do on a whiteboard, right? So don't care about any of that. It's all bad ways to pick an employee, and it leads to bad software, I think, in the end, because you're not screening for what you actually needed. And I can't speak to why places like Google are still doing it, but like I said, if the proof was in the pudding, I'd change my mind. If Google software worked, I'd say their interview process must be pretty good. But Google software is horrible, so it can't be, right? I mean, or maybe it's something else. Maybe the interview process is good and something else is bad. I couldn't tell you. But it's pretty clear that what you get out of the other end of their entire process is very low quality software. So low quality that it's laughably bad, right? You can actually get distributed file systems from 1970 that are faster than Google Drive, as far as I can tell, right? I remember using BBSs that could list the files on the BBS over a acoustic coupler modem, basically, faster than Google Drive. And they don't seem to care, right? So, or they care but can't fix it. I don't know. So, I can't say enough negative things about the level of quality that comes out of that pipeline. And why it's so low is anyone's guess. I'm not an institutional analyst, so I can't tell you why they seem to produce such consistently poor quality software. But, Time travel. Hey Casey, I know you're busy and all, but can you stand up for me and reverse this linked list on the whiteboard? Yeah, exactly. I mean, it's silly, right? It's kind of like if you were like, well, we need to do job interviews for a plumber, right? That's what we're hiring. And they come in and they're like, okay, yeah, so what we need you to do for a plumber is like stand up and uh, uh, draw for me on the whiteboard like what the cross section of a pipe would be if the outside was this thick and the inside was this, or and you're like, that does it. You don't even really do that when you're plumbing, right? It's like plumbing is not that activity, and maybe you could argue once in a while you sort of need to do this thing, but like it's really tangential, right? And again, like I'm inclined to sort of say that interview process in general does actually cause a real problem, and it leads to poor software, because what you're doing is putting an emphasis on sort of like myopic focus on quickly doing existing tricks, mental tricks. That is exactly not what gets you a well-working system that can list 800 files in less than a minute, right? The problem with Google Drive is not that somebody didn't know how to sort the names. The slowest sort in the world, an n-cubed sort, can sort 800 names probably, faster than Google Drive is right now. So that is not the problem. The problem is that what you needed is people capable of writing actual software, and that is different. Algorithms are not the hard part of software. They haven't been the hard part of software for about 2 decades, right? And so screening for people who understand algorithms is largely useless. Anyone who wrote a program incorrectly, if Google Drive's problem was that the person who wrote it used an n-cube sort, I can fix that tomorrow in 30 seconds, right? Well, no, in 30 minutes, right? All I do is go into the sort and replace it with one that works. But when you hire people who think that the way to program is you just take like the Python script and you hook it up to the thing that does left pad and then you do the blah and blah and blah, right? Who cares if that person knows how to do a log-n sort and log-n sort? Who cares? They've spent so much of the computer's resources doing nothing that it doesn't matter how fast they can make it do something, because the something took 0.1% of the time and the nothing took 99.9, right? So now you end up with a Google Drive that's sitting there for 70 years going through God knows what gyrations because of their distributed file system server has to spin up the Python instance that knows how to figure out which of these 12 GUIDs maps to the user GUID, which then goes and queries the security system for the ticket that was implemented by some other thing because we had to junction together the thing that does Google Apps versus the thing that does the personal version of Google. And oh, by the way, that runs on IPv6, but this was on IPv4. So we had to run the thing that does the translation layer to that. Oh, and by the way, that thing has a bug in it, so it actually has to redo the TCP connection every time because it accidentally leaks that handle, and we forgot about that, and so now that thing we just restart, and eventually you're somehow at the point where taking 800 file directory, the architecture is just forget it. Like there's nothing we can do, and the data's already stored across 12 different data centers, and just forget it. There's nothing I can do. You hire me to fix that, and I'm like, I can't, right? I can't fix it because it's too far gone, and it's not something that's ever going to produce a reliable, experience for the user. Random off-topic question, but why does it feel like you would enjoy knitting? I would not enjoy knitting. Sorry. I don't care for knitting. Highly repetitive processes are tough for me. These people probably make the software slow and crappy on purpose to not be fired. I don't think so. I don't think so. I think it's a skill gap. It's a skill gap. Right? I mean, another way to look at it is, suppose someone went to school for mechanical engineering, right? And I screened you on mechanical engineering knowledge. So like, tell me how load bearing this beam has to be, right? And then I take, 30 of those mechanical engineers and I put them on a construction site and I say, build this skyscraper, right? It's probably an epic disaster because they have no idea. They don't even know how to operate a crane, right? And that to me is like the Google interview process. It's interviewing people for a skill that's unrelated to the skill they actually need to do their job, right? And so the problem with that is then you get people who may or may not know how to do the job. Some mechanical engineers will probably make great carpenters or already know how to do carpentry because they did it in their spare time. Others have no idea, don't want to know, will never learn, and they just are useless at building a building, right? They could be used to design the building, but they can't build it, right? And to me, that's the problem. When you interview on an unrelated skill, you end up with workers who may or may not have that skill. May or may not have the skill you need, right? You have skill A, which is developing useful, good software that works at a high quality level. You have skill B, which is trick problems on a whiteboard. If you optimize for skill B, you have no idea if you got skill A. Sometimes you might not. You could argue that B correlates with A a little bit, and it might, a little bit, but not a lot. What are some resources to learn graphics programming? How much math is really necessary? A lot of math. I'm not sure what the best resources are, but you need a lot of math. Graphics programming in particular requires a lot of math. If you're not comfortable with math, you don't really want to be a graphics programmer. There's probably other types of programming you can do. A lot of web programming sorts of stuff doesn't really require math because a lot of the math is done for you and somewhere else. Graphics programming, you're right up in the math. Like the math is front and center. So if you don't want to learn math, don't be a graphics programmer. If not with dynamic arrays, how would you store dynamically growing data when you can't predict how much memory you will need and need to store it, so the Handmade Hero temporary memory concept doesn't solve the problem? I mean, again, can you give me an example? Like, what are you doing? And then I could tell you how I might approach it. Have you or would you ever use GoTo? I guess what I would say is I was taught programming at a time when nobody used GoTo. As a result, I don't use GoTo. I don't necessarily think that's good. I think it's probably a cognitive deficiency for me that I don't use GoTo. And I think it's probably a language design deficiency of C and C++ that they don't have a more broad idea of how GoTo integrates into code, right? Because it's pretty simplistic. So I don't use GoTo, but I should, is maybe the way I would put it. And the reason I say that is because the older I get, the more I appreciate that programming should be about telling the CPU what to do. It's not about screwing around with your language. And the only thing a CPU does is GoTo. There is no other thing a CPU does. There is the concept of a function call in the sense that there is a GoTo that automatically pushes a return value on the stack, but that's kind of an optimization, right? But GoTo is it. Like loops, there's no loops on a CPU. There's GoTos, right? There's test and jump, right? And there's no switch statements on a CPU. There's just jump. And you can do a relative, like a variable jump if you really get fancy, but compilers don't ever generate that as far as I know. So it's just test and jump, test and jump, test and jump, test and jump. So 99% of everything you typed into a computer is test and jump. You know, conditional, while, for, do, all of these, switch, test and jump, right? And so the fact that we would consider goto somehow weird or anomalous is kind of ridiculous because it's happening all the time, and why you wouldn't want access to that, I don't know. So I consider it deficient that I don't use goto. I wish that I had not developed my style of programming at that time, and at some point I probably will investigate it more, probably when I actually go ahead and just start programming my own language at some point, which is kind of inevitable, I suppose. I will make gotos a first-class citizen. Oops. Switches can in some cases generate indirect jumps. Yeah, I mean, switches can, in theory, if your compiler was super crazy, you could even have a switch statement that padded the cases, and it could jump with a expression, right? Like a computed jump. So there, like, the nature of a switch statement is such that you could do things very fancy. A lot of compilers don't do that. A lot of compilers, either just have test and jump, or they make a table and load from the table and jump. But they only do that in certain circumstances, like if they can actually guarantee that it's fairly dense, probably, I want to say. Not sure exactly what they use for their... Will you be an early adopter of JAI? I don't know. Maybe. In your experience, what do you think are good ways to manage software projects? I don't know. I don't really deal with large-scale project management. I'm kind of the wrong one to ask. Argor. The dynamic array example in 1, a list of active connections on a server, 2, an array of entities in a game. Well, in either of those, it's trivial, right? On a 64-bit computer, just put those at base addresses that have, 4 gigabytes of unused address space following them, and just grow them as necessary. Done, right? You never need to reallocate anything. You just commit more pages. If you have several unpredictably growing dynamic arrays, say in a math simulation, how would you separate by a large distance in a memory arena, or do you pile blocks on top of each other? What does the cache defer? Is it even a concern? I've never done anything exactly like that. So basically you're saying, like, well, I've got sort of random crap coming in from a user, and it could be anything, right? That I don't know what I would probably prefer. I would have to see what kinds of things shake out from actually trying it first, right? Because it depends if I see that the sizes tend to be used are similar, right? So if what you tend to get there is like, well, we get a pretty even distribution, 10 elements, 100 elements, 50 elements, whatever, and they're just kind of random. I might just use buckets. I got array chunks 0 to 32, array chunks 0 to 64, array chunks 0 to 128, whatever. And I allocate and just give those back as, like, I keep a free list of ones of certain sizes quickly, right? So just basically, a standard sort of general purpose allocator, but that's geared towards what I need would probably be all I would do. Anything large, so anything that's going to be like multiple 4K pages, I just probably map that one by itself through the OS, right? And then free it through the OS when I'm done. You know what I'm saying? Because those are so huge that just filling them up is going to take a while anyway. So I'm not so concerned about avoiding round tripping to the OS to actually change the memory map. You know what I'm saying? All right. My lord, that was a lot of questions. All right. let's close it down here, people. Thank you, everybody, for joining me for the episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along the series at home, you can always pre-order the game at handmadehero.org. It comes with source code, so if you want to follow along with it at home, you can do that. Maybe you want to play with that lighting. See if you can beat me to a good way of encoding light in there dynamically. We've got some interesting reconstruction stuff happening in there. The question is just how are we going to communicate with that reconstruction now? And I don't know. We're going to find out. That's it for today. I'll be back here next week when I will try to solve that problem, or at least take the first steps towards doing it. And I'm pretty excited about it because I think this lighting is going to look really sweet. All right, that's it for today. Hope to see you back here next weekend. Till then, have fun programming, everyone, and we'll see you all on the internet. Since it was asked today, don't forget, click on the Handmade Hero head if you want to get to any of our other Molly Rocket projects. See what's up there. Always a good thing to click on. And that's it. Take it easy.